shown to have that effect. Also, one thing that is not known, that the dose is not known, it's relatively difficult to, they do not often do that they test different doses. It's too expensive to do this type of clinical studies. Also, the matrix is often not known, or the importance of the matrix. Those two products contains the same bacteria, but would they work in the same way? Here we have the Proviva fruit drink, and here we have lyophilized bacteria in tablets. It could be that they react very differently when they come into the ecosystem. And it was also clear that most of the studies with good results has been performed on infants, children. And as you remember, I said this shaky period of the 2 first years of life, perhaps it's easier to affect that ecosystem early in life than the fully matured ecosystem of an adult. Okay, that has shown that it can work during certain conditions. Certain strains might have an effect, but how does it work? And that's more complicated. It's known in some cases that those bacteria could have an anti-inflammatory effect, or that they could produce some antimicrobial substance. But it's not often shown how it works. Some hypotheses, with bacteria come in, you have a normal microbiota that are in much higher numbers. It could be that those have an effect on the normal microbiota, and it, in its way, have an effect on the host. Or it could be a direct effect on the pathogen microbes present. Inhibition or competing with nutrients and adhesion sites. It's not very likely because those are not that many, and the different places where you can find a pathogen is huge, I would say. More likely is that they have a direct effect on the immune system or different other physiological factors of the host, that this bacteria produce different substances that interact with the host and give an enhanced host defense or normalized host function. Since we don't know exactly how they work, it has been very problematic to develop a probiotic bacteria of such a product. How should we select a bacteria that is efficient in this system? It has been very much trial and error. We don't have that many factors to select them for. There are hundreds, thousands of strains that we could use, and we can't test them all. So, from the beginning, this is I would say how we worked in the past. Okay, if we should use it for humans, we took a strain from human sources. And it could, of course, be good if it's an antimicrobial activity that we could select for at the laboratory. It should be tolerant to low pH because that's, okay, we have that in the stomach, they have to survive that. They have to stand the bile they meet in the intestine as well. Those are logical factors they have to deal with. We have, to fulfill those criteria. It might be good if they adhere to different types of cells found in the intestine. Okay, some negative sides could be if they have some antibiotic resistance genes. So we would like to avoid that, of course. And of course, they have to survive the technical properties. They have to survive in a food product. They must be possible to handle in the food production. This is very much how we have done in the past. And if we were lucky, we might have good a product with an effect. Today I would say that we're more working with tailor-made probiotics. Now we're more thinking about, okay, we would like to have a product against some inflammatory disease. Then we could have a good model, in vitro model, cell culture model, finding strains with an anti-inflammatory activity. We could work more with products that are used for infants, strains that are more adapted to that ecosystem. We also work with combinations. Could we combine probiotics with some specific nutrients? Because, as I said, they need nutrients to be active. Could we give them some nutrients that make them more active? And I think products designed in this way are now starting to come out on the market, and hopefully that will give us better products, coming products. We also work with more complex products, like complete ecosystem probiotics. I don't know if you have heard about fecal transplantation, that we more or less exchange the whole ecosystem. If it's non-functional in gut ecosystem, the only way might be to change it, so we get the new bugs coming in and exchange the old ones. Normal probiotics will just be a small part of the ecosystem. This is something that people have started to work with. Now first just with giving a fecal transplant, taking it from a healthy subject and giving that to the disease, people with a big problem. So more or less not eating fecal material, but taking the other way and changing the bacteria. But we're trying to decide how could this be more a defined collection of bacteria that could be used in that way. Okay, then the future, and we are already there to some point. Genetically modified probiotics. Could it be that those bacteria also could produce different types of cytokines, and in that way be more efficient in affecting the immune system? I mean, a factory of those cytokines at the mucosal surface. Could we let them produce, as mentioned today, different types of bioactive metabolites, like antioxidative substances, vitamins, and so on. We're also working with, could we improve adhesion activity, so they are more efficient in binding to the correct site, more efficient in binding specifically to the place where they should be active. Could we make them more tolerant to bind? Perhaps we have a very good strain in producing something, but it is killed when we eat it because it can't stand the bite in the intestine. Could we make that strain more tolerant? We also have oral vaccines, of course. Could they produce some antigens, and in that way give a vaccination for that particular antigen? Of course, we will discuss that more. Safety or maybe concern here, gene transfer, ecological fitness, and so on. I think we will come back to that a lot during this discussion later. What do I think about this? I mean, I'll come back to that as well, I think. When it comes to drugs, I would say yes. It has already been tested. That will sure come more on that they produce different types of drug-related compounds in the intestine. Food, maybe. That's a totally different story. That will perhaps come back to as well. Then we have to see a real good use for that. And the consumer, it's very much up to the consumer, of course, if they're willing to buy that type of product. So, and that was all from me. Thank you very much.